Balancing redox reactions in base is almost exactly like balancing redox reactions in acid until the very end of the problem. So let's begin by assigning some oxidation numbers. Oxygen in both cases, in the permanganate and in the manganese 4 oxide, is -2. So we know that's not the species that's changing. We can figure out what's happening with the manganese by using a mystery plus -2 times 4 equals the total charge of -1. So it looks like our manganese is going to equal 5. And then on the right side, our manganese will have a different solution. We'll have our x plus -2 times 2 equals overlord charge of 0. So our manganese will have a different oxidation number of 4 on the other side. So manganese 5, manganese 4. Okay, now we just got to handle the iodine. Iodine, when it's an ion, is -1, and then when it's just its element self, it follows the element rule of being 0. Okay, now we can identify which one is the reduction and which one is the oxidation. And by which one, I'm talking about which type of atom. The manganese numbers go down, so those are reducing, and the iodine numbers are going from negative to 0, so those are increasing. Okay, so my oxidation is going to be the iodide turning into iodine, and my reduction is going to be the permanganate ion turning into manganese 4 oxide. Okay, now it's time for balancing. The first thing I want to do is make sure that all of my elements that are not hydrogen or oxygen are balanced. Okay, so on the left side, for the oxidation, I see that I need to have 2 iodides on the left-hand side to balance the 2 molecular iodine atoms. Okay, moving on to the reduction, I see that we have the same number of manganese atoms on both sides, so we're good to go. Okay, next step, balancing the oxygens with additional waters. Okay, so I see that we have 4 oxygens on the left and 2 oxygens on the right. So I will add 2 waters to take care of those 2 extra oxygens I need. Awesome. Okay, the next step is adding hydrogen ions to take care of these hydrogens that I added to my reduction. I'm going to need a total of 4 to account for the 2 times 2 with the water. Alright, last step. We need to handle electrons. This side of my reaction has a -2 overcharge and this side has 0. So I need to write down that those iodides lost 2 electrons when they became the iodine molecule. Now on my reduction, I can see that I have 4 positive hydrogens and 1 negative permanganate for a total of +3 on the reactant side, and I do not have any charge on the product side. So that means I must have gained 3 electrons. Okay, now we're ready to rewrite the reactions to get ready to combine them. Okay, now that we have rewritten the reactions, I can see that the number of electrons in the oxidation does not match the number of electrons in the reduction. I need to make sure that these electron transfers are the same number of electrons, so I'm just going to go with my least common multiple between 2 and 3. I'm going to multiply each reaction to make sure I get 6 electrons. My reduction will be multiplied by 3, so I'll have 6 iodides making 3 iodine molecules and 6 electrons being produced. And then I'm going to multiply my reduction times 2 to make it have 6 electrons as well. So the reduction will have 6 electrons plus 8 hydrogen ions plus 2 permanganates, yielding 2 manganese 4 oxides and 4 waters. Okay, now that I'm at a good level where my electrons are going to cancel out on both sides of my equation, I'm going to rewrite my reaction so that I can clearly see how many of each kind of species I have. 6 iodides and 8 hydrogens plus 2 permanganate yields 3 iodides plus 2 manganese 4 oxides plus 4 water. Okay, now I have to remember that my reaction is happening in base instead of acid, which means I can't keep my 8 hydrogen ions around. So what I'm going to do is I'm going to eliminate those by adding 8 hydroxide ions. That will make 8 waters on this side of the reaction. Now, I can't just break laws of algebra and decide to add 8 hydroxides on one side but not the other. So I'm going to add 8 hydroxides to the other side as well. Okay, so now I can see I'm going to have to cancel a little bit of the waters. I have 4 waters on the right side and 8 waters on the left. So these waters are going to go away and the leftovers will be 4. Now I'm going to rewrite my reaction so it looks nice and clean and finished. 6 iodide ions plus 4 water molecules plus 2 permanganate ions. Oops, forgot the charge earlier. 3 iodine molecules. 2 manganese 4 oxides. And 8 hydroxide ions. And that's how you balance a redox reaction in base.